Hey, welcome to chemistry. This is the week of April 20th, and we're on lesson 2. Today we're just looking at solubility curves, so it should be real quick. We're going to start out with our cringy joke. Get it out of the way, y'all. Okay, it says handle problems with some solvent and solutes. That brings you a solution. Da-dunch. It's good stuff. Okay. A solubility curve, there's a different curve for each type of solute, usually an ionic compound. So you'll notice this is the solubility curve for potassium nitrate, KNO3. Okay. On solubility curves, it's showing you how much solute can be dissolved in a solvent over a range of temperatures. Okay. So always when we read graphs, you want to start by looking at what's labeled on each axis. Okay, so down here we've got temperature, increasing temperature on this axis, and then up here on the y-axis we've got solubility, which remember is the ability to dissolve. And it says that's how many grams can dissolve per 100 grams of water. Okay, so what we notice is you've got this direct graph that's going up, that as it gets hotter, it's dissolving better. Okay. So the graph line represents a saturated solution, okay, and it wants you to read it. It says at 25 degrees Celsius, how many grams can dissolve? So we need to first find 25 degrees, okay, between these two, and we go up to the line because that's saturated, and then we read the y value, which would be about 40 grams, okay. The second question says, at what temperature would the solution hold a maximum of 90 grams? So we're going to need to find 90 grams on the correct axis right here. We go to the graph and then read the temperature value, which looks like approximately 50 degrees Celsius. So that's one way to read this graph, is you're using the line to determine a set of conditions. The other way to read graphs like this has to do with the area above and below a curve. Okay, so a point, if I give you a mixture of blank grams and blank degrees, and if that point falls directly on the graph, then that represents a saturated solution. That's the maximum amount that can dissolve at that temperature. If I give you a combination of grams and degrees and it falls below the point, anywhere below this curve, that would represent an unsaturated solution. So for example, if it fell right here, okay, I would say, well, at 30 degrees Celsius, if I dissolve 30 grams, it's not full. It could still dissolve approximately 18 grams more to get to that line, okay? And then supersaturated is if the point falls anywhere above that curve. So let's look at some examples. Okay, right here again, now this is a different compound. We've got sodium acetate. And the sodium acetate has a slightly different graph, but it's still a direct curve. Any combination, so any point that falls below is unsaturated. Any point above, supersaturated, like Superman flies above the city. Supersaturated is above the line. Okay. Now, they're not always that simple. Okay. They're not always that simple. Sometimes we have more complicated curves, which I'll show you, but I'm going to switch over to the document camera first. Okay. Okay, so here's my notes page. I've got my first solubility curve here. So I'm going to grab some colors if I can, and I'll show y'all what we're looking at. So example 1 says, if I'm going to dissolve 70 grams at 50 degrees. Okay, I just want to plot that point. So my grams and my degrees. Really, the only problems I find from students is you switch them, okay? You'll get grams and Celsius backwards. So 70 grams is this value at 50 degrees, and we're here at this value as well. So if I come over right there, that point would fall there. So because it's underneath the saturation curve, I would call this an unsaturated solution. And I'm just going to put unsat, like that, okay? For number 2, it says 60 grams dissolved at 20 degrees. So 60 grams dissolved at 20 degrees. And then I come up and over and say right there. So that solution clearly is above the line, so we're going to call that supersaturated. Okay. You must have used heat or something to force all 60 of those grams to dissolve. And then number 3 says 35 grams, so I'm going to approximate right about here. 35 grams dissolved at 40 degrees. Okay, so that looks like it's right about there, which is another unsaturated. Now, for your quiz and homework check, we really try to be pretty clear with the points that we pick. So if you plot a point and it looks like it's right there and you can't tell if it's on the line, if it's a point that close, we're trying to show you it's on the line. Otherwise, we'll be really clear with it's clearly below it or clearly above it. Okay, so don't stress too much trying to decide if it's saturated or not. All right, let's look down here now at this example. So this is much more common what you're going to see. In fact, it's actually very hard for us to find solubility curves that has just one salt or one solute on it. It's much, much, much more common for you to have multiple like this. Now mine printed in color, which you can barely tell. A lot of y'all is probably printed in black and white. The one on your homework check is a much simpler curve. I think there's only 4 different choices, but I wanted to show you what it looks like with all of them. Okay, so it asks you for this solubility curve, now with all of these different salts, which one is the least soluble at 10 degrees Celsius? So least soluble means dissolving the worst. Okay, which one's the lowest on my solubility? So at 10 degrees right here, the first one I get to is this line. And I'm going to follow that until I see KClO3. So that one is the least soluble at that temperature. KClO3. Okay, because it only dissolves about 6 grams. That's not very good. All right, number 2 says how much PbNO3 can be dissolved at 20 degrees Celsius. So the first thing I want to do is find that, and I'm going to grab a highlighter and say for me, I'm going to use that lead nitrate as a yellow. That way my eye knows I'm just focusing at this line. Okay, so how much can be dissolved at 20 degrees? Well, 20 degrees is right here. Okay, and at 20 degrees it looks like it's a little bit more than halfway between those two. So I'd say probably 56 grams, maybe 57 grams. If you say 55, it's okay, right? Like there's a range there. It's not a super precise graph, but that's how we read it. Number 3 says, where do KCl and NaCl have the same solubility? Now really what we're looking for here is the intersection of the graph. So again, I'm going to take out some colors and I'm going to just randomly pick and say NaCl is going to be blue. So I see NaCl here, it's above this line, and I'm just going to highlight that in blue so it stands out to my eye a little bit better. And for KCl, I'm going to go with pink because I have a pink highlighter right here. Okay, KCl, I can see it right here. So I'm going to just go like that. That way my eye knows I'm just looking at those two. And where do they intersect? They intersect right there. It looks like maybe just in front of this line. So if you want to say anywhere really from like 27 to 30 degrees, any answer choice in that range would be fine. Probably closer to 29, but that's fine. Where do potassium nitrate and lead nitrate have the same solubility? So I've already made this one my yellow line. Okay, I'm going to grab green, I guess. Okay, for KNO3. We'll find KNO3 on here. Oh, there it is. And it already kind of was green. Or do they have the same solubility? Well, they're intersecting up here. Again, kind of right in front of this line. And that line is equal to 50. So I'd say an acceptable answer range, I'm going to write it to the right-hand side, would be like 47 to 50 degrees Celsius. Any answer in there would look good. And then number 5. NaCl I've already colored in as my blue, so I know I can ignore everything on this graph except for my blue line. It says if 30 grams of NaCl is dissolved at 40 degrees. So this is a lot like what we were doing up here at this graph. The solution would be blank. So 30 grams is this value. At 40 degrees, this value. And I'm going to say it's right here. And that's clearly under my blue NaCl line. So under means unsaturated. I'll put unsaturated. Okay. Really, if we were trying to be a little more rigorous, so in class I would say how many more grams could dissolve. So, well, if it's dissolved 30 at that temperature, how many more could dissolve? It looks like about 8 more grams could dissolve, or 7. But we're going to try and keep it simple for you. All right, don't stress too much. Take a look at that homework check. The graph on your homework check is the same one on your quiz for this week. Good job, y'all.